everyone, and thank you, Mandy, for having me. I'm really excited, and I'm always happy to talk about topics I really care about and I'm really interested in myself. And I'm excited to see so many people interested in, hopefully, this field as well. So I'm Justina, and I work at RASA, which is a Berlin-based company. And what we do, we develop open source software for conversational AI. So if you would want to build your own Google Assistant, your own Siri, that's a software stack you can use, and I hope you will do after my presentation. So I work as a developer advocate, so I'm a mixture of data scientist, ML engineer, and in general what I care about is that developers have all the resources and the tools to create something cool with RASA. So I write tutorials, I talk at conferences, and I build projects and break things and then talk about it. So all this stuff. Yeah, and today I'm going to talk about how we can build contextual assistants with machine learning and open source tools. And my talk is going to be probably a bit more technical than other talks, but I hope it's okay. So over the years, we have seen such a big shift when it comes to technology and how users interact with technology. It all started with a huge attention to web apps and websites, and companies paying huge amount of money to make sure that websites look nice and that users can interact with them using mouse and keyboard. And then we saw such a huge shift to mobile apps, so every single product had their own app, well, still has. And then the interaction between technology and the users shifted to this touch-based interaction. And now we see such a big opportunity to bring AI assistants closer to the users, and actually we already see adoption of AI assistants because it's getting pretty normal to find Google Assistant or Alexa at people's houses, and people are using them already for different tasks and interactions. And at RASA we see such a huge opportunity to enable even more people to use that, and also to empower developers to build AI assistants that work for everyone. However, when it comes to building AI assistants, there are lots of different challenges, and even though there are some solutions already out there, again provided by big companies like Google, Amazon, and so on, Facebook for example as well. The problem is that they kind of give a solution, one solution for a variety of problems, but companies these days and developers themselves, they want to build assistants that work for their own specific company, their own specific product, which means that those assistants, they have to work in a quite specific domain for quite specific users, and it's really difficult to apply this kind of one solution fits all technique to build good AI assistants. So what companies and developers ideally want is AI that is built in-house. However, it's not an easy task to achieve as well, because there are lots of different challenges that come with it. So, for example, we obviously need a team of great machine learning experts, and you probably know that it's not an easy task to complete, because finding good talent, especially in ML field, is still quite a big challenge. Also, if you want to build AI in-house, you have to build the entire ML infrastructure yourself. So that's again quite a difficult engineering problem that your company has to tackle. And also then you have to take care of integrations into apps and backend systems, and that is another quite challenging and cumbersome problem that you basically need a big team to achieve all that. And that's why what I see in the industry is that a lot of developers and companies, when they build AI assistants, they use quite simple but such limited approaches when it comes to building AI. And here I have a very simple example of that. So basically, majority of AI assistants built to this day, they are built using a set of rules or a state machine. However, if you want to build an assistant that would scale in production, that would work for a variety of different users, you have to go beyond that, because I used state machines before myself and tried to build some assistants using just rules. and things get really complicated very quickly when you try to design a dialogue which at least look like a little bit more natural, like something that good users have, but it's the architecture of such a system grows so quickly that it just becomes so difficult to even find where in the architecture you have to make improvements and build your assistant, and then you basically spend more time just going through the architecture of your assistant than actually improving it. So this is what we try to tackle at RASA. So we take a completely different approach to building AI assistants, and we use machine learning and real conversational data for all that. And as a result, at RASA we developed an open source stack called RASA stack, which consists of 2 Python libraries. First one is called RASA NLU, so just like the name suggests, it's a library for natural language understanding, so you can build machine learning models to enable your assistant to understand what the user means, what they ask for, and so on. And another one is called RASA Core, which is a machine learning-based dialogue management system. So it uses real conversational data to observe how people talk to assistants, and then using that data, the model predicts how an assistant should respond in a specific state of the conversation based on the context and lots of other details. We obviously have a community of developers that are using RASA already, and these are just a few reasons why we see that they already like to use RASA stack for their projects. So first of all, it's customizable, it's open source, so you can see everything that is under the hood, starting with just the code, ending with all the hyperparameters of the models, so you can tune them and you can really adapt the entire framework to best suit your use case. Also, since it's open source and free, you basically own it. You just take it and use it for your own project. So there's no vendor lock-in, and there's no risk that we would take away something, or that you would have to wait a really long time to develop your assistant or your system, because you can always add your own components to the stack. So you don't really depend on anyone. And also, it empowers developers because actually using RASA, even though it's machine learning based, you can use it and you can build AI assistants with it, even though maybe you don't know much about machine learning. So it's quite user friendly as well. So if you were using RASA and you wanted to build AI assistant with RASA, this is the architecture you would probably end up with. So the main component, and the first component actually, is a connector module. So it's messaging app or some kind of voice system that you want to use, basically connects the user and your assistant. And then once the user asks some questions, for example, if they want to change their address to something new, the message will be sent to the input module, so-called ears. And this is where RASA NLU model stands, takes that input, extracts important details, and that help assistant to understand what was the user input, and sends them to the machine learning-based dialogue management component, so-called brain. And this is where RASA core model stands. So it takes all these details, also observes the context, what happened previously in the conversation, and makes predictions how to respond. Those responses can be lots of different things. It can be some kind of simple message response, or it can be some kind of backend integration, for example, API call, or taking some data from the database and using that to provide the response. And then all these details are sent to the output module, which is simply responsible of taking details from a dialogue model and creating a response in a simple human language that the user can then understand and then continue the conversation. So now I would like to dive a little bit deeper into how developing a system with RASA stack looks like. So you will see where the machine learning hides, and a little bit more of how that actually works. So the first stage is NLU stage, so enabling your system to understand user inputs. And the main goal is to take unstructured user inputs in a simple human language and build a model that can extract structured data, because this is how a computer program can actually understand human language. And this structured data consists of two components. first one is called intent. So it's just a label that represents the overall intention of what the user input or question was about. And another component is called entity. There can be lots of different entities as well. They are details or important pieces of information that would be useful for an assistant later on when it has to decide how to respond or what specifically to do based on user's input. So, looks quite simple, but there actually are quite a lot of challenges when it comes to this, even just an NLU part. One of them is how to enable assistant to handle natural conversations. So when a user sends an input or a question, when actually there is more than one meaning in user's input. So how do you build models that can actually tackle that? We worked on this quite a lot at RASA, and we built a model. It's called TensorFlow embedding model that basically can achieve this task. So when the user sends a message that has more than one intention, or there are maybe two questions in one message, an assistant about the model can actually assign two intent labels to this input, and that allows much more natural conversations, and it's just in general how the assistant behaves looks more human-like. So the model that is used, as I said, is called TensorFlow embedding model. We call this approach in general a supervised word vectors from scratch approach because we don't use any pre-trained word vectors. Basically, the model learns from the data that is provided by the developer. And it's a writing model, so the model learns embeddings for the messages, for the inputs, and then all of the intents. And after calculating the similarity between the new input and all of the intents, the model basically produces the most probable intent labels. And this model is also based on Star Space research paper, which was written by Facebook. So I highly encourage you to read this paper as well, because it will give you lots of details about the model itself and also other use cases. But the main advantages of this approach is that it not only allows you to build assistants that can identify those multi-intents, but also you're not really limited to what kind of languages you can build your assistants in, because you don't use any pre-trained word vectors. And then you can build assistants in really specific domains as well. So lots of advantages. The next stage is entity extraction. So it's a bit different process. So user input goes through tokenization. So a token can be one word, and then model extracts features, which are fed into named entity recognition model, which then predicts what word in a sentence is an entity, and also what kind of entity it is. So for example, in here, user input was what's the weather like tomorrow, and the model will predict that date is an entity, and the value of this entity is tomorrow. So how that works in practice. So let's say we have a user input, what's the weather like tomorrow, and the model that is under the hood by default in RASA, but if you want, you can modify that, is called conditional random field model, which works very similar way as a skipgram model. But the result that is produced by this model is, again, what word in a sentence is an entity, and also what is the value of this entity. So how this works. The model takes into account not only the target word that is checking if it is an entity or not, but also the surrounding word, so the word before and the word after. And the model obviously extracts features from all of these words. So for example, it can check if the word before is a lowercase word, is it a title, is it an uppercase. Also, it will extract features from the target word. Is it what kind of prefix it has, what kind of suffix it has, is it a digit, and other features. The same with the word after, and this is how it learns. And then in a training phase, if we have, obviously we will have labeled data, so the model will know, and it will learn that if there is this word with an entity label date, and surrounding words also have these specific features, this is how it learns how to predict that in unseen user inputs. Some of the words in a sentence might be entities as well. So this is just one part of an assistant to enable assistant to understand the user. Another important part is to enable assistant to think of how to respond. And this is called dialogue management. So now let's take a look at what's under the hood there. So first of all, why dialogue management with RASA core? So again, as I have mentioned previously already, rules and state machines, they don't scale. And in general, I think the end goal of building a chatbot or a voice assistant is to actually build an application that can kind of mimic a human. Like, that's what we want. We want natural conversations and assistants that work well. So probably there is no better way than to actually learn from humans, like how they talk. And that's the approach we take. We look at real conversational data and allow assistants to learn from that. Also, we take put a lot of attention to closing the feedback loop, because it's important when you build your assistant, things change, people change. And just like with any other machine learning model, data changes. So it's not like you just build a model, you deploy it in production, and that's it, you forget about it. You constantly have to go back, check, make changes. So the same with chatbots. The best way to improve your assistant is to actually take feedback from the users and to use that and improve your assistant over time. And also, I already mentioned that as well, but it's quite easy to use RASA Stack and build something really quickly. So you can build a prototype in a matter of, I would say, 20 to 30 minutes, something that works, something that you can show to your friends, and something that doesn't really need a lot of training to get people started. Yeah, so as I said, RASA core dialogue management side learns from real conversational data, and here is just one example of how it looks like. So on the right-hand side, you see an actual conversation between the user and an assistant. So you can see it's something related to booking hotels. And then the only thing that has to be done to this data is it has to be converted into the RASA format. And this format means that user inputs have to be converted into corresponding intent labels, and user inputs have to be converted into corresponding action names. And that's it. But then basically this is one story. We call them stories. So this is one conversation. You will probably, definitely need more than one, at least a few. But this is the data that assistant will learn from. And a dive into what is under the hood. So we have user input, simple, what's the weather like tomorrow? Obviously, an LU model plays an important part, because depending on what the user asked, the assistant will make decisions how to respond. So an LU model does its job. It classifies intent, extracts entities if there are any, and passes them to the model, which is the current neural network. And in a simple words, it means that this model not only looks at what happened at that specific state of the conversation, but also what happened previously. And this is how this context is added to the model, so that the brain of an assistant is a little bit better at predicting how to respond. So first, model gets previous state, so what kind of actions an assistant executed, and what kind of questions the user asked. And then current state of the conversation also goes into the model, so what the user asked right now. And using the data, model makes prediction on how to respond, what is the most probable action or response that it should produce. Also, as I said, those responses can be different things, so there can be API calls, and if an assistant extracts some important information that should influence the predictions of the next actions and how the conversation goes in the next stages, they can also be added then back to the model. So basically the cycle continues, and then at the end, obviously, there will be a response at some point produced. And also there can be one user input and few actions or responses, so it doesn't have to be just one action, one response, communication all the time. And the last part of the development that is also super important is called closing the feedback loop. So improving an assistant using the user feedback. So this is what we call interactive learning at RASA. So we already empower developers and allow them to talk to an assistant and provide feedback at every step of the conversation and correct an assistant, and it can learn from that feedback. So let's say user asks something, and in an interactive learning session, assistant, instead of responding immediately with some kind of response or an action, it actually tells the user what it thinks, like what kind of intent predictions it made, what kind of entities it extracted, and also what it thinks it should respond with, like what kind of action to execute, and so on. And if a developer sees that it's wrong, a developer can tell an assistant, you made a mistake, you should have done this instead, or should have understood my input in this specific way, and then assistant takes that input and learns through it, and this is how an assistant improves and corrects itself. So yeah, I definitely encourage you to check out the RASA docs to see more details on that and how it works in practice. And also, we actually built an actual assistant using RASA Stack. So you can actually go on RASA docs right now and talk to it. It's called Sarah, which is our mascot as well. RASA, Sarah. Yeah, and just see how it works in practice, and yeah, you can learn more about RASA by talking to Sarah. And I will finish with some key takeaways and tips, so things that I've learned by working with developers and just seeing what kind of things they build. And I hope they're going to be useful tips for you if you consider building an assistant. So first one, and probably the most important one, is to allow your users to help you improve your assistant. So it's quite easy to get into this mindset that, oh, I have to generate all the training data myself, and only when my bot is perfect, I will give it to the users. Well, the thing is, real users will probably really surprise you when you will see what kind of conversations they have with your assistant, what kind of things they ask, what kind of things they need. And by giving your assistant early to the actual users, you will validate the idea of your assistant, you will learn what kind of new skills you should add to your assistant, and also get a lot of good training data, like real-world training data, which is the best to improve your assistant on. Also, getting training data in the first place, like those conversations, it's quite tricky because conversational data, unfortunately, is not the type of data that just lays around on the web somewhere. It's not something you can find easily if you're starting from scratch. So my suggestion would be, if you're starting from the very, very beginning, just observe how your users interact with your product right now. So for example, you can look at where users look for information on your website, and what kind of things they are looking for, what kind of questions they send to your customer services people, and use that to just at least design some basic skills of your assistant. And yeah, don't be afraid to customize your tools, because as I said, I personally don't believe that there is one machine learning algorithm or one tool that fits all the use cases, and especially in conversational AI field, it's important to be flexible and customize the frameworks you use to build the best conversational AI. And also, start small. That's really important as well. I see a lot of developers just jumping into the development, designing hundreds of different skills, and then really struggling to first get enough training data, and then struggling to manage everything and making sure that everything works well. So my suggestion would be start with just 1 or 2 skills, make sure they work well, and then improve your assistant, add new skills over time, because the cool thing about conversational AI is that you can improve it and develop over time, so you don't have to cover everything in just one iteration. Yeah, even though we do a lot of work on NLP and dialogue management at RASA, and in general, I'm amazed with how much the field and research have achieved already, and I'm really curious and excited to see where it goes in the future. But there are still so many challenges out there, and NLP is definitely far from being a solved problem. There are things like negation that still has to be solved, and for example, how you build a system that is good at more than one thing. So for example, a system that can book hotels, restaurants, tell you, I don't know, anything, and basically a system that can do more than one task in more than one domain. So that's still quite a challenging task to tackle. So if you're interested in these challenges and a lot more, we are building open source community around RASA tools, because again, it's open source, and this is where it really strives from. And these are the things that we care about, is to give developers open source software that they can use, that they can build, that they can change, about community, so people that actually are interested in this field, and also applied research, so something that is actually actionable that people can use and that goes beyond just research papers. So if you're interested in this field, just join our community. We have thousands of members on our forums and around 300 contributors that already contributed code or some kind of developer education content. So if you would be interested in that, definitely join. And if you have more questions, I think maybe I still have a few minutes to answer some, but if you have more, feel free to reach out. This is my email, my Twitter, so I'm always happy to talk about conversational AI. Thank you.